right, now we're getting started. Sorry. Well, thank you for everyone coming to December's meetup. It's a great turnout. We're very honored to have Patty here tonight talking about robotics and machine learning with NVIDIA. And we have representatives from NVIDIA. We have a lot of representatives from Patty's company. So there's plenty of opportunities to talk if you're interested in the work. Before we get started, I try to thank the sponsors because they help make this happen. So Vera Technologies is a defense contractor. They've been working with us for several years now. And actually, Nate's in the back if you're interested in learning more. He's the one with the Amazon Web Services car box. So we're actually in discussions of doing an event in the future where he would come and show you guys how to program those autonomous vehicles and maybe play around with them a little bit. ATG. So
I didn't see that. Is that a deep racer?
Yeah.
Okay, excuse me.
Yeah. Have fun. So we lost the speaker, so we're good. So ATG has been with us also for a while, Applied Technology Group. They do a lot of work in the government space also, and commercial, and they do data science and software engineering. Did you just take this? Just take the racer? Clarity, is anyone from Clarity here? So Clarity is another defense contractor. Smaller, but they're also doing data science, software engineering, system engineering, really great company. They also run the MongoDB user group if you're interested. Next Century recently acquired CACI, or CACI, but they've been working with us for a while. They're now a larger defense contractor, so if you're interested in working for a larger company, let me know and I can point you in the right direction. Miner Cash is a non-defense contractor, but they're a data science boutique or consulting company. They do a lot of work up and down the coast. They've been sponsoring for a while, and actually I think one of their employees is speaking at another meetup tonight. But if you're interested in learning more about what they're doing, let me know and I can make the intro. Ares Ventures is my company, really small, defense contracting. If you're interested in learning more, you can talk to me, obviously. So NVIDIA was kind enough to provide the kits that we're raffling, and I wanted to give them an opportunity to introduce themselves if this thing stops playing. All right, do you want to introduce yourself and say hi?
Sure. So I'm Larry Brown. I'm the manager of the Solutions Architecture team at NVIDIA that covers down on Federal. I've got my colleague Rob Zubert here, one of our account executives that kind of wrangles things here in Central Maryland. And thanks to Patty so much for putting on a great presentation tonight. I can't wait to see it. You guys are going to learn a ton about our embedded side of the NVIDIA portfolio. As you all may know, we have a range of GPU offerings that goes from a little embedded side, the stuff you'll see today, out to GPUs that are many hundreds of watts and go into data centers and power the world's fastest supercomputers. As some of you may know, the fastest supercomputer in the world today is the Summit supercomputer that's run by the Department of Energy down in Oak Ridge, Tennessee. And that's an NVIDIA GPU-powered supercomputer. NVIDIA's been in the high-performance computing space for well over a decade, actually building high-performance supercomputers. The fastest supercomputer in Europe is an NVIDIA supercomputer. The fastest supercomputer in Japan is an NVIDIA supercomputer, and so on. So we do this embedded thing. We do high-performance computing. And by the way, I'm hiring for the Federal Solutions Architecture team as well. So feel free to come up and talk to me about that. Thank you.
So UBC is where we're at. So they have a data science program, a computer science program. Patty actually teaches here, so if you're interested in learning more about the program, you can talk to Patty, I think. Or you can talk to me and I can put you in touch with some of the directors and program directors. All right, quick announcements. So I just posted next month's. It's going to be January 21st. It's going to actually be a workshop focused on how to use machine learning for cyber data. So they're actually going to walk through a problem of doing, I think it's supervised learning and breaking down like a cyber situation. And then in February, it's going to be Databricks, probably discussing their new product called Delta Lake. I don't know where that will be yet. We have a newsletter. It hasn't gone out this month because I'm behind. All sponsors are hiring. Everyone's hiring. If you're interested in being involved in the meetup, just contact me, walk up, or send me an email. And with that, I want to introduce Patty. Her bio is a little out of date. I didn't get the chance to update it, but she is now the Senior Director of Data Science at New Wave Telecom and Technologies. I have heard they're hiring, so if you're interested, you can talk to Patty. She's been coming to the meetups for a while, and she's very passionate and enthusiastic. I think it's going to be awesome. So just the last thing, at the very end, I am going to raffle everything, but what I'm going to do is randomly call people. I have 4 books, 3 kits, and a ton of t-shirts. So I'm just going to start listing up names, and I'm going to mark the ones that get the kits. But anyway, I didn't get the kits. It's whatever you come up and you take. I'm one per item, but I'm just going to let you take what you want. With that, I'm going to hand it over. Thanks. Yeah, you can have a t-shirt.
Wow, I would have been happy if I had 20 people. So the fact that I've got this many, I'm really honored. And thank you, Jason, because I think it's really cool that I just get to show up and talk. And he did all of the work. I just posted a few things on LinkedIn. So actually, let me switch my slide deck too. All right. I kind of got distracted by the deep racer, so. All right, give me 1 second. I'm going to put my slide deck on. So I meant to be here earlier because there we go. I was going to be here at like 5:30 so I could set up and pre-train some of the stuff, and then I happened to look on the website and it said that he was going to start at 8. So I was like, oh, I can take my time. So now and I ended up having to kind of rush it, so I kind of hate being rushed, but we'll be okay. So yes, you already know about me. I am a total geek, and I just started a new job at Oh, yeah, I need to speak here. I like to walk around, so I'm gonna have to stay by the microphone now. So yes, so I am a total geek. I followed like GPUs, before they were called GPUs, back in the 90s, and I enjoyed playing computer games. I would buy Quake and Unreal, and then I would look for the latest graphics cards. MechWarrior, any MechWarrior fans? And so I kind of got into it then, and I was upgrading my graphics cards and stuff. And you guys remember 3DFX? And then NVIDIA seemed to be the one who won the graphics wars, kind of. So they're still around, and then you have AMD. But I don't see AMD much in the data science space. So when I attended some meetups, I started hearing about how graphics processing units are really geared towards improving data science. And since I do work in that lane, I started paying attention, and there's a lot of potential, so it's really exciting, and we'll talk more about that. So I just started a new job. I'm week 3 at New Wave Telecom and Technologies. So everything's been like a blur, and I'm wrapping up the semester. I taught 2 classes this semester too, and so I think next time I'll just teach 1 because it was a bit much. So starting my new gig. So here I am getting hired as like supposedly the superstar data science person, and I found out the first week that we had our holiday party. So and it was a fancy holiday party, and I'm not really one who is. I always get help when I have to go to an event on what to wear and stuff like that. So that Friday. So my first week was that Friday. So the holiday party was at the museum, Baltimore Museum of Industry. So I wore a fancy dress. I wore these heels. I went to the party. Was meeting all of the executives and the owner, and so here's where my geekness comes into play. So I'm much better with robots than I am with social graces. So I go to the party. They have these really cool acrobatics, and I'm standing there watching these acrobatics, and it's really nice. And I have a glass of wine, but the night just started, so I don't drink a lot anyways. But I'm standing there, and I can't even blame it on being drunk or even walking. I was just standing there. I crossed one foot over the other, and I went down. And not only did I go down, I knocked the table over, I heard glass breaking, and we have plastic cups, so I don't even know what it was that broke. So hi New Wave employees, I hope you guys didn't see that, but now you know. So as far as I know, I'm not fired yet, so. And I don't know, so one of the things I think about is we use deep learning neural networks to emulate human behavior, but I don't know that my behavior would be something that anybody wants to emulate, at least in the physical world. So, so today we're going to talk about robotics and machine learning. So I'm going to give you just a brief definition so that we're on the same page. We're going to talk about graphics processing units a little bit. We're going to talk about NVIDIA. And I even have a slide, which is why I went and got the deep racer. I have a slide on the deep racer too, because there's a little story behind it. I also went to the Amazon Summit last year when they had it, and I entered the deep racer contest just out as a fluke, and I came in third. So I have a lot of trophies. But I was a Fed back then, so I couldn't take the car that they gave, and I couldn't take the jackets. And the only thing I took was the trophy. And hopefully the trophy's not worth more than $20. At least that's what I told the contract people. So I kept that. And we're going to talk about the Jetson kits, and if time permits, I'll actually try to go through and run a lab on training the JetBot. So I brought this little guy here, and I'll show you more about that later. And also, if he has enough power, hopefully he won't run out of battery. Okay, so this is, I really wish I had a microphone. So robotics and machine learning, artificial intelligence. It used to be that the definition of artificial intelligence was to emulate human performance, but I think we should expand that to also include biological performance, because when I went to the Johns Hopkins physics lab, they were doing some demos on some cool AI stuff that they were doing. They actually had a little mini AI unit where they had replicated the brain of a worm. And so, and I think a worm has, like they said, like 200 and something neural pathways. And it actually acted like a worm. It like crawled around, looked for sun and stuff like that. It was very basic. Now they say the human brain, that at least that's what they said at that presentation, has 87 billion neural pathways. And then machine learning is in robotics. It's actually a subcategory of AI. And then the robotics that I'm talking about isn't like, so everybody talks robot process automation is kind of different. That's more software based. It's more of something to emulate workflows and stuff on a desktop. But when I talk about robotics, I tend to refer to what is defined on robotics.ieee.org, and that is an autonomous machine capable of sensing its environment, carrying out computations to make decisions, and performing actions in the real world. And if my voice gets slow, just let me know if you can't hear me. And then machine learning itself, so we'll get to that in the next couple slides. But machine learning really enables machines to infer an outcome based on pre-trained data. And there's several categories of machine learning that we're getting pretty formal with it now. I know Gartner has this article where it defines the categories as diagnostic, predictive, and prescriptive. And so that's true. And we'll primarily be talking about predictive here. The one thing that I want to really make sense is when I talk about machine learning, there's a lot of discussion on ethics. I think my first time I met one of the execs at New Wave, he asked me an ethics question, like, what do you think about ethics? And and then my family, like in my family, it's about my family and friends, I'm the only technical one, so I'm usually surrounded by a lot of people who care about shopping and movies and stuff. But they all have this, they watch the media and they have this inflated sense of what AI is and stuff. And so there's a thought that AI can take over the world. But, from my personal experience and what I try to, because it's really hard to explain neural networks and deep learning to somebody who's not technical. So the way I see it is more it's out of the box. Like when I first start training something, it just doesn't work. And when I first, half the time when I fire this up, I run into errors. So it's rather complicated. And this is from LinkedIn. So that's pretty much what you get with a neural network until you train it on lots of data, and there is a very important component that is needed for any neural network. And somebody tell me what that is? Just besides data.
Tagging.
What did you say, tagging?
Tagging.
Okay, somebody give him whatever, t-shirt. So yes, neural networks, even the best neural network, when they talk about machines can learn, and then you see pictures of a robot playing piano or anything, there is no neural network that I know of, unless there's something I don't know of, but there's no neural network that starts from nothing. So there's lots of really cool network architectures out there. There's AlexNet, like for images that have these models of images. Somebody initially had to go in and start with images that was labeled, handwriting, anything. So there's no way that if I put a phone in front of the JetBot and it recognizes it, that it recognizes it without having any input. It recognizes it because it is using a model of pre-trained, where somebody initially had a bunch of images and labeled those images. And so in the upcoming future, you can't take the human equation out of our AI. You still need people to identify what the objects are, and I'm working on some interesting projects for the government. I won't say which one, but because now I'm a contractor and I don't quite know what I'm allowed to say or not say. But and some of my coworkers are back there, are also working on the same stuff. But we're building models that are related to healthcare and trying to improve healthcare delivery. And it requires us working side by side with subject matter experts, physicians, nurses, and insurance, and people who know the data. And so it's not just, there's nothing that we can just throw at it and expect it to work magically. Even data scientists still rely on subject matter experts to make sense of the data. And I will share these slides, and so this is a really good article that you guys can read about. But again, there's somebody here that says, this is a cat and this is a dog. And then based on thousands of images, then it will have a model of label data. Then you train your model. Then you go ahead and feed it new data, and you can make an inference based on existing data. Okay, so this is actually an NVIDIA slide. So I'm also an ambassador for NVIDIA. I recently got certified as a university ambassador, and I'm certified in 3 tracks: computer vision, parallel computing, and rapids. So I have access to all their course materials and stuff that I'm really happy about. So one of the things that enables deep learning really just means a neural network that has lots and lots of layers. That's what it means. And so yes, there's that, but what really enabled this was advances in computing power. So back in, if you even think like 20 years ago, you couldn't have done what we do now. You couldn't have done the kind of inference I could do on the JetBot. I probably would have needed the supercomputer from IBM or Oak Ridge. So computing power has helped. GPU, graphics processing unit, was the other big advancement that enabled AI, and I'll talk more about why GPUs help and how they differ from CPUs. And then the other thing was just big data. We have lots of data, now we have the computing power to make use of it. And so with neural networks, the best thing you can do is give it lots of data and lots of power. And lots of good data too, that kind of makes a difference. And so one of the things about deep learning, with a lot of if you look at the labs for JetBot, the models that JetBot pretty much uses are neural networks, and more specifically convolutional neural network. And if we go back here, this is a neural network, and if you look at this is what you would call fully connected layers. That means these are your nodes, and that means that your input and you have your outputs. It means that every node is connected to the next layer of every node. There's a connection to every node. And so that differs from, that's your classic neural network, that differs from your convolutional neural network Convolutional neural networks have, what they do is it filters images through a series of layers, and it does many things. It filters the images and it reduces them, and it actually starts looking at low-level features. It's for like looking at color, edges, shapes, and as it goes through each layer, it will progressively extract more features and more features till it gets to the point that at the end of it, you end up having a fully connected layer at the end of that, where it will classify the object. But as it progresses through the layers, and you can have hundreds and hundreds and hundreds of layers, then you can get to the point where it can start to say, okay, if this has an ear, is it a cat ear or something like that? Is it an animal? It can start to differentiate between the kind of feature that might make it specific to an object, identifying an animal versus a chair versus a phone or something like that. And so convolutional neural networks do very well for images. And if you click on this link, and actually I could click on the link, and I turned 50 last year, and my eyesight, like whenever I look at my computer, I have to wear my glasses. So it sucks getting old. So let me click on this one. I just want to show you the different models that are available. So PyTorch is a framework within Python that you can use. It's one of the many that you can use to train and work with neural networks. And these are some of the model architectures that you can start with. And we'll talk about more of that. But AlexNet was one of the models that for that the ImageNet, I think it was called ImageNet, right? There was a contest to classify a bunch of images that were posted, and AlexNet was the first one who won it. And the couple guys, they went and they were able to take a neural network and GPU enable it and optimize it, and it just blew everybody away. And then after that, then you had other people come up and they came up with their own versions of network. Like Google Net has a pretty decent neural network too, and it kind of optimizes it not just for GPUs but also based on computing, and it optimized the way the CPU was used. So there's different ones you can play with. So and when I show the lab later on the JetBot, we're actually using AlexNet on some of them. So let me go back to our slide. So, now I can see it again. All right, so, and the other thing is transfer learning. So that is the latest thing that you may hear about with regards to neural networks. So what transfer learning is it is actually a way that machines can learn based on existing models. But, and this is a really good video. I encourage everybody to watch it. Andrew, and I think, I'm not sure how you say his last name, but somebody say something? Amy. Okay, that's what I thought. So he has an excellent video on explaining this, and he explains it so simply that you know students really know it in and out. But so transfer learning is where you will take an existing neural network like AlexNet, and you'll take, instead of having the outputs, you may adjust the outputs and add a couple layers and add your own images. So the example in the video that he talks about, and I thought it made sense, was like you might have 1,000 radiologist images, and that's not a lot of data, and so if you go with something where there's where AlexNet may have millions of data, or it's trained on much more, because of the way convolutional neural networks work, a lot of the filters and features are applicable in general. Like you can take what has already been learned on that neural network, and you don't have to retrain everything. And so it works where you can take that and then train it with the additional images for those last two layers, and then you can actually inference and learn new things about these images. It works in that manner if you're using it against an existing model that has lots of images, and then you're giving it new data that doesn't have as many images. It doesn't work in the reverse. So if you're trying to use 1,000 radiology images and you're trying to train a large data set, that's not applicable. So that's probably the closest example that you can get to of saying, yes, machines can learn. And like I said, unless there's something I don't know about, because the only other thing I can think of is machines don't learn innately like children do, like people do, unless you program them to. And if you program them to, that's pretty, even like so I brought this one little vehicle here. This is, I call him Linus. He's a basic Arduino-based vehicle, so not that smart. Everything that he does, it's based on if you see this, you do this. It's very rules-based, which is fine because rules-based is actually easier to program and it's very accurate. But it's not flexible and it doesn't account for any variances. So, all right, so let's talk about GPUs, my favorite thing. So, yes, they can be used to accelerate machine learning. But the one thing you have to remember is they don't work by themselves, so you have to pass the data from the CPUs to the GPUs. GPUs are different. You could say they're lots of mini cores and they're simple cores. So what makes them sophisticated is the volume. But if you compare one of those little mini cores to a CPU, well, a CPU is engineered differently, and we'll talk more specific to that. But so like the best way I can compare, because there was a video and I showed it to some of my students. I don't know if anybody saw the Mythbusters video there was a Mythbusters video of them having a paintball and doing a painting sequentially, like with a happy face. And if you Google it, Mythbusters GPU on YouTube, you'll see it. And then they showed a gun that just made a Mona Lisa painting in a second. But I wouldn't equate that because CPUs are actually much more sophisticated than that example. So I do want to clarify that. But here's where GPUs are useful. Let's say I'm stranded on an island and I hear there's a storm coming and I need to get out as soon as possible. So I can take a speedboat and I can get out of there very fast, right, and go back to the mainland. But what if all of us, if you guys are stranded with me on that island, how many trips is that speedboat, even though it's pretty fast, going to have to make to get us all off the island? It's going to have to make a bunch of return trips. So it would be better to get a much slower but bigger ship that we could all go at once. So there's some overhead with using this ship, but in the long run, it's much, much faster to transport all of us. So that's the best example that I can think of comparing a CPU to a GPU. If you don't have a lot of data, if your computation is very simple, especially if it's sequential, you really don't want to use a GPU because you could actually have the reverse happen. You could actually slow things down. So you need to make sure that your use case is right. So let's just briefly, and keep an eye on the time too. So it's already 7:30. That's okay, so I'll have to talk a little faster. So CPUs are optimized for serial tasks, and they have very large amounts of main memory. The clock speeds are fast. Their main goal of a CPU is to just take that computation and get it done as fast as possible. So, cache misses are very costly. What that means is if your data isn't readily available in cache. That means it has to read it from disk, which is going to slow it down. And then low performance for what? CPUs use a lot of power, and they're very power hungry. So, so if you can offload it to a GPU, you actually can conserve. Well, that's one of the reasons why we can do machine learning on embedded vehicles now, because they don't need as much. The Nanos don't require as much power if I were to do it on a computer. Because you wouldn't want to put my laptop on that. So, and then comparing GPUs have, you can see the difference in the registers. And then, so here they have lots of cores, and they're geared for throughput, and it performs well per watt, because the design of each core is much simpler than a CPU. Relatively low memory capacity, that's the weakness, is low thread for performance. So each individual thread is not going to perform as well as a CPU thread, just because it's not sophisticated. It's smaller in nature, simpler. NVIDIA. So I didn't know the NVIDIA guys were going to be here, so I'm really, I don't need to, well anyways. So I talked about the history. Yes, they were some survivors of the graphics chipboard, and they were the ones who actually coined the term graphics processing units, and enabled it for complex computations and analytics. And I don't know how that came to be, I just know that that's the case. So, and then if you go to this website, this is everything on about Jetson. Whoever maintains this website, it's a resource that I go to quite a bit, so I just put it there for your reference. And Amdal does all. So this is a good thing to think about, a good formula to use on what the speed it will be for if you want a GPU enable your application. And so, how this helps me is looking at the number of cores that I have. So this little JetBot here has 128, I think, CUDA cores. This Jetson TX2, and I'll unbox that later, has 256 CUDA cores. And so where you plug that into is right here. The more cores, the faster your computation. And so if you're comparing performance, and then the other thing is what you're speeding up is only the part of the code that can be run in parallel, that can be optimized for GPUs. So, so in this instance, if I had 60% of my code that could be optimized, and I had 256 CUDA cores, I could achieve a speed improvement of 2.5 times. So that's the way to use the formulas. All things considered, if you're comparing it to something like there's a new Raspberry Pi 4 out, if you're comparing it to that, you also have to take into account memory and processing speed too. So use this formula when you're considering all things equal. So I would almost compare it to if I'm running a program on my laptop and it's by default it's running on CPU, and I want to see what the speed it will be if I offload a portion of that to the GPU. Okay, so the developer kits. So now we're going to get to why we're here. Now that you've heard the spiel about deep learning and GPUs. So I was looking at the developer kit a couple years ago to see if it was something I could bring into the classroom. I was evaluating them. Well, that was my excuse anyways. So, and at the time when I first looked at them, they only had the TX1s. They had TK1 was the first generation, and they had TX1, and then they had TX2. And so these are developer kits. Now they do use them in real-world applications, not just for hobbyists and stuff. But they are kits, like especially this one. The TX2 is pretty much a little mini supercomputer, and it actually comes with it actually has a built-in camera and built-in Wi-Fi, and where the Jetson you need to put an SD card, it doesn't come with memory. This has memory and stuff, and it's preloaded with Ubuntu. But it's more to it than that. So it's really easy. You can get that, and it comes with a power cord and everything. Out of the box, you can plug it into a monitor keyboard and boot it into Ubuntu and start working with it. So that was their first kit, and I think when it first came out, it was like $6.99. I convinced, so I bought one, I have one at home, and then I convinced, when I worked at Social Security, I was really lucky because I worked in the Advanced Data Analytics Lab, and also our CIO was has a master's in engineering, so I was able to sweet talk them into letting me buy some stuff there. And so I originally was looking, they had this one kit called the Jet Robot Kit, and that's the kit that I built, but I had to leave that with, when I left SSA, I had to leave my kids behind. So, and it was, and I have this cartoon because it kind of reminds me of what I went through when I was building the Jet Robot Kit. And this is an example of somebody being really complex. They're locked out, they're asking their roommate to let them in. Tried their cell phone, but it's off. Tried, you guys remember internet relay chat from way back when? Only the older people, well remember, but, and then couldn't find anything to throw out the window, so then he SSH'd into the Mac mini in the living room, got the speech synthesizer to yell for her. I think the volume's down, so he's researching how to turn the volume up, and then the person who walked in was like, I take it the doorbell doesn't work. So, and he's like, what? So sometimes things can be very complicated, but if it's part of the learning process, it's okay. I did have fun building the Jet Robot Kit. It was initially came in all of these little parts, and it ended up, I ended up building this. There's an X unit and a Y unit, so for those who are still at Social Security on the first floor, Butcher, you still work there. That's where they're showcased there. So, and they're about like this big, and it was pretty complicated, so it took me a while to build. There was lots of soldering I had to do. I don't have a background data science and programming is my background, so some of the other stuff I have to figure it out and have people mentor me. I was lucky enough that somebody introduced me to an electrician at Social Security. I didn't know they had an electrician, so I spent weeks with him, and he helped me wire and showed me all the ropes and how to solder properly. And so it was a team effort, so we built this, and the first time I powered it on, I was like, oh cool, it actually works. But there was more to it, and that was just the build part, so it was a heavy build process. And then the programming part I found was pretty complicated too, and it wasn't that, the part that was complex about it was you had to have all these pieces that work together, and they had to have the right versions. So you needed Ubuntu, that's fine. But you all needed a specific version of Ubuntu, which was 16.04. You needed the robot operating system because that's what you needed to get the robot. This original version wasn't like the Nano. It needed an Arduino to interact with the wheels and the motors and the sensors, and these are 3 sonar sensors. So sonar sensors are these little things that are used to detect distance by bouncing sound off of them, off the objects. And then it had a camera and stuff. So you need the Arduino, and to work with that, you need the robot operating system was the piece that connected everything together. And then, of course, and then you needed the NVIDIA GPU libraries, and then you needed Arduino sketches. You needed to know Python and C++ to get it all to work. And so it took a while. It wasn't that expensive. So for $2,000 plus the Jetson kit, I was able to build one. So if you think about buying something like that off the shelf, it could be pretty pricey. And so this kit is no longer, but you could buy it at Servo City at one point, but they don't sell it anymore. But the bill of materials are still available, and if you click on that link, you'll have a spreadsheet. So you can actually order all these things. There's a lot of parts, so it might be kind of painful to do that. But you can. I still wish they sold it because I actually want to build another one. And then this toolkit here actually has all of the instructions on how to build it and how to program it, how to get started. And then there's a really good reference on the TX2. So, and I have this slide in here called the Turtlebot because there's a lot of similarities. So if you want something similar that's kind of, that you could order, it's a little bit more pricey. This Turtlebot, there's a lot, it uses pretty much the similar kind of concepts of the ROS, Ubuntu. Same, if you learn the Turtlebot, you'll pretty much know how to work on the TX2. A little bit of difference, it uses a netbook instead of the TX2. But, so, and then I'll skip over this because I'm running. We can run over, right?
Yeah.
Okay. So if you guys can't stay, sorry, but I'll just keep talking. I'll skip the Jetter because I really want to get to the Nano. But I will say that some of the challenges that I had with the TX2 was it's not for novices. You definitely have to know how to program. It's helpful if you know Ubuntu really well. And then some of the things that I run into, like I will tell you that I built it and it was great. And then there's a thing you have to do where you have to have a host machine to work with it, and that's to flash the latest tools on it. So I would do that, and I would get everything loaded, the CUDA software loaded, and that would take like half a day to do all that. So pretty much sometimes my whole weekend I would spend working on these things. It kept happening where I would get it loaded, then I would install ROS, the robot operating system, and then I would reboot, and then suddenly I couldn't connect to a monitor anymore. It's like I kept calling it the black screen of death. And the only thing I could do was reflash it and see what, and I was just troubleshooting. And so how I ended up figuring out what was wrong was, because I read through all the documentation, I Googled the heck out of the internet, and so I went to the GTC conference and then spoke to an engineer there, and he told me what the problem was. And that problem was actually listed on the reference site, but under TK1, not under TX2. So all I had to do was from now on, now I know, and from now on, whenever I install and flash everything, to run this command first, and then it works. And so it was a simple thing, but this is the kind of, and maybe somebody who is more familiar with Linux, with Ubuntu systems than I am, probably would have figured that out on their own. But anyways, so that, so there's little challenges like that. There's lots of troubleshooting you have to do. And then also, it is very specific to it. There's certain things that are only compatible with like ROS has different versions. So Kinetic, Melodia is the most recent one. So Kinetic works with 1604, which is what works with those labs. So, so you just have to be aware of that. So it's pretty complicated. So then the Nano came along, and so everything should be made as simple as possible, but not simpler, right? And so here's my slide on the deep racer. So the reason I have this slide here is because after I finished building the TX2 and I was like showing it off, and I had some Amazon guys in the lab, and I was showing off what I built with them. And then this guy named Harsh, I don't know if you guys know, but he was one of the Amazon guys. He said, "Why don't you just get a deep racer?" And I was like, "What are you talking about?" And he was like, "Well, we have a deep racer. All you have to do is plug it in, and you can train models." And I was like, "Well, did you have it a year ago?" He was like, "No." I was like, "Okay, well, that's why I didn't get one." Because it had just come out. And then they also had the deep lens camera, which is cool too. So deep racer. So that's deep racer. You guys see it. It's a little different than the Nano though, because it is cloud-based. So you have to have. So yes, you can buy the car. The car is actually not that expensive. I think it's like $399 or something. Because I'm going to get one. I'm going to get New Wave to buy me one. But you also have to have an account on Amazon, and you have to train it on SageMaker and stuff. And so I know they have a free tier, but I'm just not sure. Like somebody like me will probably get past that free tier pretty quick. So that's the only thing I have to warn you about. But other than that, you can get up and running pretty quickly. You buy it, it works. You can actually just learn. And at the conference, they have a workshop on where you pre-train the models in their workshop on a virtual environment, and then you load it onto the track to see how it performs in the physical track. So you can get a deep racer if you want. And then the mics. So if you have kids, high school and stuff, this little card here is like the perfect thing to get them started in robotics, because it's very easy. It is a build, but it's a super easy build. You can buy it off Amazon for like $50. It's an Arduino-based vehicle, rules-based, but they actually have to build the whole thing. They don't have to solder anything. And it's got a little sonar sensor, so it's a cute little guy. And I'll actually demo it real quick. So for those who have to leave, you can see something working before you go. But I gotta kick it off from my phone. So this is what I would recommend you start with for somebody who wants to learn about robotics. And it's pretty easy, but it's complicated enough that they are actually learning how to control and write code, and it's just basic C code. And I've got to connect with Bluetooth, and then it'll work. Oh, it's going to fall off the edge. He's not that smart, sorry guys. But he does use sonar to look for, to detect distance, and then he can turn around and stuff. So that's your basic. So this is a lot of fun for kids. But that's as much as it can do. You could technically take this and add a Raspberry Pi or Nano and make them smarter. So minus, I will do that one day, I promise.
That'll be like a vacuum cleaner, right?
What's
That'll be
that?
like a vacuum cleaner? We'll talk about
Yeah. Yeah, the same thing, right? Because that's what they do too. I think they're getting a little bit more sophisticated there. I don't have one. I probably should get one one of these days. Okay, so and now we have the Nano. So and then so they've got the Nanos in the back. I have 3 at home. So one of them's on that. There are other ones. There's another race car that I'm building at home. Actually, my son has mostly built it because he wanted some really expensive shoes. And I told him, he's 15, I told him if he build the robot that I didn't have time to build, that I would get him the shoes. So. But he's taking how longer to build it, so I didn't have it ready for this. But it's actually based on the donkey cart kit, so it's pretty cool. So this is the Nano, so that's what's on the JetBot. And it's smaller than the TX2. It only has 128 CUDA cores, where the TX2 has 256. It uses less power. It's still capable of machine learning. There's a little SD card that you have to put in. You have to preload it with the image. It's really easy though. They made it compatible with the Raspberry Pi and the Adafruit, which is great because I don't have to worry about RAWs. Now you could get it to work with that, but the way that they have these images preloaded is you can hook it up. Once you flash it, even with this, when you put the image on it, then you can connect to it. You first have to get it connected to Wi-Fi. So the first time that you load the image, you need to hook it up to a monitor and keyboard and mouse, and then you have to connect it to your Wi-Fi. Once you do that, you can write down the IP address. Then after that, you don't have to ever connect it again. You can connect to it through a laptop and use Jupyter Labs. And I like the way that they set it up. So this is really, I think, going to do well in the classroom because it's a much less build requirement. And then there's actually, for those who win the Nanos tonight, check out this link. And this is a course that NVIDIA has on getting started with AI, the Jetson Nano. There's a couple of parts you're going to have to get. So these don't come with power cords. I don't know why. So so you have to buy a power cord, and it doesn't come with the SD card. But other than that, and it doesn't come with Wi-Fi either. So you have to remember to do that. The first JetBot that they originally had, they had the bill of materials, and then you had to print the chassis. And that's the hard. It is kind of hard to find components that fit these, or even the TX2. It's hard to find enclosures and stuff for that. So 3D printing is the way to go. But now they have, if you Google Amazon and look for like solderless JetBot kit, you can get these kits that have everything. So I actually did that. I cheated. So I bought a solderless kit, and it was like another $100. And so it came with the pre-printed chassis and the Wi-Fi and the CPU fan and the wheels and all that. So and then the batteries. The one thing that it didn't come with that I didn't expect, because I put it all together, I was getting it ready to go, and I was actually going to bring it to class, was it didn't come with something to charge the batteries with. So I was like, oh man, I can't charge the battery, so I couldn't show it to my students because I waited till the last minute, which is typical for me. So I ordered it from Amazon, didn't come in time. So now I have the battery. So it's just, there's little things like that, but other than that, it's a pretty cool kit. It even has little switches to turn it on and off. And then this little LED light, when you turn it on, it will actually show the IP address. Once you have it connected to Wi-Fi, from now on, when you boot it on, the IP address is loaded on there. So that's cool. I like that feature. Okay, so let's see what else. And I'm walking away from the microphone. So guys, remind me if you can't hear me. So the Nano, so it does have an HDMI port. When I first got here, I hooked it up to the monitor and stuff so that I could connect it to Wi-Fi. Power is supplied through the micro USB port. There is a barrel jack, and it's 5 volt. Either way, you're going to have to buy one of them. If you do decide to power it through here, you have to, there's a jumper, I think it's that one. You have to, no, it's this one, it's this one. You have to put a jumper on it to disable the power from here, and then you would just use it just for connectivity to a PC. So, and then, and then there's your typical Raspberry Pi pin for expansion. And there's a camera connector over here, and you can either connect the camera through the USB port, or there's a little mini CSI camera connector, and they have these little Raspberry Pi cameras, and that's what I have on the JetBot. So, and then there's a little micro SD slot that's kind of hidden that you put right under this. You kind of slide it under. Okay, and it is really simple. You literally, within an hour, you can get your Nano up and running, even less. You just have to download the image, and you use a utility. One of them is Etcher. That's what NVIDIA recommends that you use. And then you can take that and flash it to your SD card, and then really you just load it, and it takes really about, I'd say like 20 minutes or so, and then you're ready to go, and you can power it up and use it. And they have different images, and so there's one image that is for just like regular machine learning and stuff. This image is for a JetBot, so some of them will have different labs loaded. But you can also upload your lab and share it. And then once you have it configured, then you just put in the IP address and call on 888, and you can connect to as long as you're on the same network, you can connect. So, and then I just put some extra links on there. There's a lot of information. There's YouTube videos. There's a lot of people really getting into it. There's GitHub has all of the sample code for all of the labs to do collision avoidance, road racing, so your basics. And then if you don't have a JetBot, if you don't have a JetBot and you just have this, there's actually quite a few labs to do, all you have to do is hook up a camera, and you can do things like image detection. And they have some really cool labs like one of them's like a gesture one to detect like whether you're thumbs up or thumbs down. And there's another one for like facial emotions and stuff like that. So there's a lot of stuff that you can do. And it's pretty easy to get up and running. Okay, and then the other thing the honorable mention is the Xavier. So he's the big boy on the block. It's a lot like the TX2, just more CUDA cores, a lot more CUDA cores. And so this is the heavy duty one, and then here's some of the other developed kits. I really suggest if you're new to it, or if you're like doing it to work with your kids or students, that you start with the Nano and then work your way up if you want to, if you have a need to. So the Xavier, they did buy one at Social Security, but I don't work there anymore, so I'm going to have to get New Wave to buy one. So the Xavier has different versions, that you go 384 or 512 CUDA cores, and then lots more cores. And then they're actually getting more sophisticated with their processor too. And then you can see the specs for the TX2 and the Nano. I don't really have TX1, or I don't even know if you can get a TK1 anymore. And then there's a new Xavier NX that's coming out, which is supposed to be a smaller version of it with with lower power consumption and less memory and stuff like that, but with a lot of CUDA cores. It's for pre-order, so I just give it an honorable mention. And there's something else I would tell you. Okay, so I'm gonna connect to the JetBot, and it's 8 o'clock. So for those who want to stay, I'll kind of go through some of the labs and show how to train a neural network. If you want to see it, it's up to you. But you can also, all of the resources to do all of that's also posted in your links. Why don't, since it's 8 o'clock, why don't I go ahead and see if anybody has any questions, and then I'll go into the labs for those who want to stick around. Does that sound okay?
I would say go ahead and do the lab. I mean,
Okay.
yeah, go ahead.
Yeah, because you guys have nothing better to do right than sleep. So, okay, so let's do the lab then. I'll just leave my mouse. Okay, so what I love about whoever idea it was to load the Nano with Jupyter Labs, they're brilliant. So I personally would love to shake their hand. And then I need to know what the IP address is. So you have to know what your IP address is, but once you do, you pretty much just type that in and then :888, and it'll take you to. So I'm actually logging into the JetBot right now. And if you get prompted for a password, it's JetBot. So this is Jupyter Labs, and so I'm actually connected to the JetBot. And you can see, if you browse, you'll see some of the folders that are on the JetBot. And then there's some notebooks that are preloaded. And for those, hopefully you guys have seen notebooks and you know that it's a way to interact with Python, right? So there might be some newbies who don't use Python, so this might look a little different. So let's just look at the basic Notion notebook and we'll load that real quick. So all of the libraries are to interact with the robot. They've done a great job of incorporating it into Python and making it easy. So you can just take these notebooks and execute the cell, and they have really clear explanations of what each part does. Sometimes I've had certain instances where this code will freeze, and then I just have to power down the unit and bring it back up. So, but that doesn't seem to be happening right this minute. So obviously for those Python folks, you have to import your libraries first, and then you can create an instance of the robot class. And then,
You make sure the robot has clearance.
he does. You know what, the way with the antennas are placed, I always think that the back is the front. So I sometimes will do that by mistake, but okay, so actually it should be might be low on battery, but it should actually be spinning. Try it. to power it down. All right, so let me power this down and bring it back up, and then we'll try again. This worked at home, so. But it does, the battery tends to drain pretty quickly, and I probably should have powered it off. So it'll take a minute to power back up. And then I'll try again.
So Patty, I had a question. So as you're waiting, like what kind of stuff are you doing with the robots? I mean, what are you personally doing?
It's more for educational purposes. So I'm hoping, well, one of the things is I use it as a way to teach deep learning, and I also find that when I bring that to a meeting with executives who don't really care about machine learning, it gets them interested. So it's kind of like a marketing tool. But really, for me, it's more educational because I actually don't work for APL or anybody that needs it. But, and I also, from my perspective, is I'm interested in research and embedded and computing and data management. And so I like the fact that, it started up again, that I can experiment with data on a small form factor, because everything is cloud-based. But I still think there needs to be a lot more work done for the data management side. And so the cloud is great for like deep racer, but what happens when you don't have internet connection? Or if you're out in the field, if you're in if you're in a country, you still need. So I think, in my personal opinion, I think that the cloud has turned everything into a black box. So I worked in a data center years ago, and we hosted data before it was called the cloud. And so I don't like that when I talk to these cloud vendors that they don't tell you, like, I want to know what S3 is. I want to know how you figured it, and it's proprietary now. You can't know any of it. Where before we used to, like when I worked in data, we used to let the customers tour it and give them a show them what we engineered. Like I remember when we before 64-bit was prevalent, and we were experimenting with titanium servers. And so I like the hands-on aspect of being able to test the performance of data and programming and computing. And I'm not convinced that, I think the cloud is good. I think edge computing is better, and I think there's still a lot of work. And I still think we need a lot more to do with, even like with data storage and relational databases. Nobody's really doing anything with relational data. It's all big data. It's all NoSQL and stuff. So, that's like a long answer, and with the JetBots, it's just one of the ways to help me experiment with some of that stuff. I am not actually very good at building things, so, but I like to program it, and so I like that the Nano actually gets me to that process that I can use it quicker. So let me go ahead and get back to this, and hopefully, yes. Thank you. Sounded like one of my students too. Okay, so let me go. I'm going to actually, because we're so late, I'm going to show you the basics of one of the of how neural networks work, and hopefully this will work. So in order to train a neural network, and at least we can get somewhat far into this, is you first have to collect the data. And so this is the human equation that I was getting into, and it's a little slow, but okay, so there's the, at least it works and the camera's working. So that's the view that the Nano sees. And so now we have to, so this is the command to create directories where we store images. the directories already exist, so it's letting me know that. And I actually was playing around with it at home, so there's images of my basement. And then, and we're going to create a couple widgets, because the goal here, and you can see I added a bunch, is to actually start training it on how to identify what's free and what's blocked. And it's not going to do anything yet because I have to wire the functions up to the button, so let's do that. Okay. And so now I can actually go and train it. And so I might need a volunteer. So what you would literally do is, and this is why I brought all some of the stuff in here, is you would actually train it on like images. So like, how do you identify if something's blocked or free? And so when, for the nanos, for the JetBots, that's what they literally do, is somebody will sit here and say, okay, put an image of a teddy bear in front of it, because there might be a teddy bear on your floor, you never know.
Back of the front.
Yeah, we showed that earlier.
Yeah. So, well, and so then I would say, okay, this is an image of a block, because I don't want it to run into that thing. So, and then I would need to go and do it, you know, for however, maybe he'll approach it from the side, so I would do that. And when you're at home, you're actually standing by but it's much quicker. You're clicking and moving the image around. Going back and forth like this takes a while. So, and you would just keep doing that, and you would do it for like any other images. So I was having fun, like playing around with a dog and a cup, you know, just, and so you would keep training it, and then of course you would do the opposite, you know, just to let it know when something's free. So, and then you would turn it around and so that is the basics of building a model and training something specific to your environment. And you actually want to spend time doing this, you know, hundreds of images. So I'll step through this, and let's just, I think we're just confirming that the images are there. And then what the next step is, it'll actually create a data set, which is already one here because I created it earlier. Actually, I'm going to delete it and create it again. Okay. So, and then after that, the next part is you will actually train your model. And so typically, the nice thing about this, the way that they have with Jupyter Labs, is you really want to train it on a better machine than the Nano. This machine isn't really good for that, but if I was at work where I have a better machine, what I would do is I would download this to that machine, and I would download the notebook, and I would train it on that machine, as long as I had the proper libraries and everything that I needed. I can go ahead and get as far as I can here. So I'm gonna import some of the libraries that I need to train the model. And I'm not gonna, but we can tell it to him. And then once this one's done, then we can go and create a data set instance and
Yeah, you didn't have to give it input for.
Where do you leave that file?
It's right here.
Nope.
It's right there. Yeah, so there's the data set one. It's just taken a while.
I think it's prompting you.
Yeah.
It's asking you.
Right below it, it says replace data set block, blah, 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 blah.
Here, why?
I don't see.
Yeah, you see where lost it. The currently executing code block, right below it, it says replace data set block, blah, blah, blah.
Okay. I can delete it and unzip it again.
Well, if that's on the robot though, is it?
It is, so it's slower, it's much slower on the robot, because that's where I'm doing it from. Okay, so it unzipped it, and then the next step that it needs to do is it needs to transform the images, because the way that the camera reads it in isn't the format that it needs to actually submit it to the model. Okay, so that's done. So now we're going to create a data set to train, and we're going to do our usual train and test data set, and then we are going to load the data. And now we're going to, is that done? Yes. Keep your fingers crossed that everything keeps working right. So, and then now we're going to define the neural network. So we're using AlexNet, and this may take a little bit because it's going to download so the existing data from AlexNet, and then it's going to do the transfer learning on the new stuff. And so then after that, it will classify it. And then, now here is the critical part that this is the piece that will actually tell you to execute it on the GPU and transfer the data to the GPU. So if I did not run this code block, it would automatically run it on the CPU, and it would take a lot longer. So I definitely want to make sure I run that code block. And then we're getting to the, I'm actually going to delete this model here. Okay, good. So now we're going to actually train the neural network, and we're going to have it do about 30 passes through, they call each pass an epoch. And so let's just go ahead and do that. And once this is done, it should put my model out there. There should be a new file called best model path. And then we can actually test it out. It's probably not going to do really well because I obviously didn't really go and take images. And sometimes your rooms are going to be different than the lighting, and things can affect how it sees. It might see too much noise. So. But see that you guys could do this, right? This is pretty easy. So
All these notebooks were included with...
yes, they're all, I did not have to write any of this code. NVIDIA provided it all. So, and there's a lot of, you can just go to GitHub. I have the links in the slide deck, so just click on them from the slide deck. Or you can even Google JetBot NVIDIA, and it'll take you to the GitHub site. So this does take a little bit, especially because I'm doing it on the JetBot, just slower, but it will finish.
So you said there's 128 cores on the Nano?
Yes. So obviously, if you have a machine that has like the newest RTX or something, that's 1,040, and then there's some that have even your basic 1060 GeForce cards have a lot more cores than that. So, but it's 128 cores is sufficient to run a model. It still has some significant speed up.
All right, the first epic just finished?
Is it finished? No.
No, the first epic just finished? Oh. Stop saying that. One for two epics.
Oh, yeah, I think.
Yeah, I'm sorry, guys.
30 times.
But at least you see what it's involved, right?
I can see one now.
It's just one pass.
So, I mean, so you could envision taking this around your house and training it on all the obstacles, your kids' toys, your pets, and stuff, making sure it doesn't run into the cat and the dog.
I got one.
The question, are you being impacted because you're not using external power?
It would probably help if I had external power, yeah, but that's okay. It will finish eventually, so.
Hey Patty, do you want to take a couple questions and then I can do the raffle?
Yeah, so I mean, well, they are asking, oh, yeah, you want to do the raffle?
I was going to let you do a couple questions and
Okay,
then I'll
well,
do that.
ask away guys while we're waiting.
Who's going to install TensorFlow on nanos?
So it comes preloaded?
No,
Oh, you TensorFlow.
and a specific question, because I've on the NVIDIA platforms, and for some reason, they do a warning if you're going to try to install TensorFlow on an AGX. But then there's a specific.
Well, you know more than I do then, because I haven't got that far with them.
But it says you can install it on the Nano, so I'm just trying to figure out.
Ask the guys in the back, they might know. So did you guys hear, this gentleman up here is asking about installing TensorFlow on Nano. And he said he gets warnings, so I don't know if you, I don't know the answer, so,
Okay, I'll
but, yes.
So, have you considered using one of the, we had a board, considered putting that board into like an iRobot, because they've got a platform that's not packaged in it's just a learning platform,
Oh, do they? I did not know that.
but you could put the brains onto the.
So like the TX,
Right,
that's pretty cool.
but I was just wondering if you consider doing that before.
I have not, but I would love to check that out if you, can you share that link?
I mean, what the link was, yes, I just seen it advertised.
I've not seen that yet. I think it sounds cool. Any other questions while we're waiting?
Step on his box.